Welcome to this build session. My name is Anthony Chen, and I'm a program manager on the Windows IoT team. Today, I'm so excited to be talking to you about building Windows IoT devices on NXP's i.MX 8 SoC family, not just because we've launched a new platform, but because it's about something much bigger and much more important for our partners, and that is silicon diversity. You see, today, if you want to build a Windows IoT device, you're limited to picking between Intel or AMD silicon. And this really constrains our partners on price, on power, form factor, and ultimately makes it difficult to compete in a number of markets and device verticals. So by launching the NXP i.MX 8 platform, we're really building out an ecosystem of Arm64 Windows IoT devices, giving our partners the power of choice. Let's dive into what this platform is all about. I'm going to start by going over the Windows IoT team's Arm journey that led us to this launch. Then I'll discuss what is the i.MX 8M and Windows IoT Enterprise platform. Finally, I'll briefly touch on how you can get started building with this platform and show a little demo. So let's start by going through the Windows IoT on Arm64 journey. It all started over 5 years ago, where we worked on the NXP i.MX 6 and i.MX 7. We released a preview program for that against Windows 10 IoT Core in 2018. We followed that up in 2019 with a GA, or commercial availability. In 2020, there was a brief pause where all of us were dealing with a global pandemic. And then 2021, we moved to the i.MX 8 family on Windows 10 IoT Enterprise. And that brings us to today, where we now have GA, or commercial availability, for Windows 10 IoT Enterprise with NXP i.MX 8. So I go through this journey for two reasons. I want to emphasize two things. First, we believe that Arm silicon is a long-term investment for us, and that's evidenced by the fact we've been continuously investing in it for over 5 years. We know that you can't just build an ecosystem overnight. It takes many, many years of building, iterating, and bringing partners like you along with us. The second thing I want to emphasize is that while the i.MX 8 platform is a new, it's a new product, it's a new launch for us, it builds upon thousands of hours of work done by Microsoft and NXP engineers together. It's a refinement of the previous i.MX 6 and i.MX 7 BSPs of Windows 10 IoT Core, all packed together. So what happened to i.MX 6 and i.MX 7 on IoT Core? We announced commercial availability of it in 2019, but it ultimately wasn't a success. So, we took a hard look on why that was the case, as we wanted to build our new platform. And it came down to three reasons. First, with i.MX 6 and i.MX 7 on Windows IoT Core, you were limited to building apps using the Universal Windows platform. And that was really constraining for a lot of our customers who had existing Win32 apps that they couldn't just port over easily to UWP. In some cases, they couldn't do it at all because there were APIs that were not available to them. The second reason was that the i.MX 6 and i.MX 7 had graphics acceleration hardware capabilities. However, Windows, we didn't have a GPU driver, a Windows GPU driver for that. And so graphics performance wasn't competitive with what you could get on Linux. So the third reason was that BSP releases came out too slowly and the support model was too ambiguous. Microsoft, when we first launched i.MX 6 and i.MX 7 on Windows IoT Core, we published a BSP on GitHub, which then we archived and handed over to NXP. And then they published a BSP with no promise of support at all. And that did not align with customers who are used to the 10-year long-term support model of Windows. So we took these learnings and put together a new platform, the i.MX 8 on Windows IoT Enterprise platform. So with the feedback that customers could not just build UWP apps, Windows IoT Enterprise gave you all Win32 apps. We added a GPU driver that supported the Windows DirectX 11 API. And we put together a roadmap with multiple BSP releases this year alone, and support available for this BSP for 10 years, aligning to the Windows long-term service model. So with that, let's define what i.MX 8 on Windows IoT Enterprise actually is. So I'm going to first start by talking about i.MX 8, and then I'll talk about Windows IoT Enterprise. When we say we're supporting the NXP i.MX 8 SoC family, we're talking about a range of NXP Arm64 SoCs. So there's 3 classes in this range. There's a performance class, which includes the i.MX 8M and the i.MX 8M Plus. And with these SoCs, you'll get the highest clock speeds, the most capable graphics. Then there's a budget class that includes the i.MX 8M Mini and the i.MX 8M Nano, and these will be lower priced. Finally, there's an automotive class, the i.MX 8X, which has a bunch of features that are specific to automotive scenarios. In addition, support for i.MX 8 is going to look like multiple NXP-supported BSP releases, each with increasing functionality. The initial BSP will target supporting a few simple device types. And then with each additional BSP release this year, you should expect additional features added needed to target additional device types and scenarios. Now let's look at the Windows IoT Enterprise side of this platform. Windows IoT Enterprise is fundamentally very different than Windows IoT Core. It's equivalent to Windows Client Enterprise. So if you're familiar with working on Windows, which a lot of you probably are, you should be very familiar with it. You get the desktop shell. You can have all the different windows instead of a single app like Windows IoT Core. They can all be running at the same time. And if you're, like I said, if you're familiar working with Windows, Windows IoT Enterprise will feel exactly the same. There will be 2 additions that we will offer for the i.MX 8. We're targeting Windows 10 IoT Enterprise 21H2 GAC, which stands for the General Availability Channel. And what this edition gives you is feature updates, security updates through 2025. And then there's going to be the Windows 10 IoT Enterprise LTSC 2021 OS. And this gives you the 10-year support security updates through 2031. Now, we talked about how Windows IoT Enterprise fixed the issues of Windows IoT Core by improving app compatibility, allowing you to support all Win32 apps. Let's dive into that in a little more detail. So with Windows IoT Enterprise, you get support for all Win32 apps. And so that means all app development frameworks that you can use on Windows will just work on Windows IoT Enterprise with NXP i.MX 8. So on the right, you can see kind of a table that compares the two. And that just shows you how limiting IoT Core was. With IoT Enterprise, we had a lot of customers that told us that they were building apps that were Windows Forms based or based on .NET Framework or WPF based. And you couldn't do that easily on IoT Core. With IoT Enterprise, you get support for all of those frameworks. Anything that runs on Windows Client will run on Windows IoT Enterprise. And so this minimizes the application porting effort for customers who are used to working in Windows. For example, they come from a Windows desktop client world, or they come from Windows CE world. These app development frameworks are all supported. The second thing we talked about improving with Windows IoT Enterprise and i.MX 8 is adding a GPU driver so that we can utilize the graphics hardware capabilities on the SoC. So we partnered with Verisilicon over the last 2 years to develop a GPU driver for the GC7000 Lite GPU that is on the i.MX 8 SoC family. This included GPU driver supports the Windows DirectX 11 API. This is the DirectX that supports AAA games amongst other rich Windows graphics. Now, apps not using DirectX 11 APIs are still going to be performing very well using Windows Advanced Rasterization Platform. They'll be rendered on CPU as opposed to GPU. So on the right, I have a table that goes through our roadmap for the different types of applications and workloads that will run on the GPU driver that we built with Verisilicon. So initially, it will be any apps that use the DirectX 11 API, the Windows Shell, Desktop Windows Manager, which uses the DX11 API, and any Universal Windows Platform apps, which uses the WinUI library for controls and other UI. Later this year, we plan on adding support for GDI APIs, which is used for some older Win32 graphics libraries, like MFC or ATL controls. We plan on adding support for end-to-end video playback processing, which includes both the encode, which includes the decode, and things like resizing and pixel format changing from YEV to RGB. And we plan to add support for the Chrome Edge browser, as well as Windows Presentation Foundation applications. So we're going to start with just a DirectX 11 API, and we're going to add additional functionality for this GPU driver throughout the course of this year. The third thing I talked about us improving with the shift from i.MX 6 and i.MX 7 and Windows IoT Core to i.MX 8 on Windows IoT Enterprise was BSP agility and the support model. So with that feedback, we have a roadmap this year that includes 4 BSP releases, 5 if you count the public preview that happened in March. So today we're at GA, and what that means is we have support for the i.MX 8M SoC and the i.MX 8M Mini SoC. It'll include Verisilicon GPU support, and we have support for the Windows 10 IoT Enterprise 21H2 GAC OS, General Availability Channel OS. This release targets gateways and basic HMIs. So like I mentioned earlier, we plan on starting with some simpler IoT device types and building it up over time. In June, we plan to add support for the i.MX 8M Plus SoC, as well as the i.MX 8M Nano SoC. And we also plan to announce GA for the LTSC version of the Windows 10 IoT Enterprise OS. With this BSP release, we also plan to add additional features that'll allow us to target industrial automation use cases and device types. In September, we'll follow it up with another BSP release where we add support for the i.MX 8X automotive SoC. And you'll see additional features and bug fixes to support use cases like tablets, robotics, and automotive scenarios, such as very good power management and battery charging, such as camera support, such as rich sensor samples. And then finally, in December, we plan a final feature and bug fix release for the i.MX 8 SoCs that we support for this year. So that's what our roadmap looks like for this year. Now, how do I get started building the NXP i.MX 8? First, you want to get the hardware. So get the i.MX 8M EVK board from an NXP distributor, or you can customize the BSP for your own hardware design if you are building your own hardware design. And we'll have a number of partner boards that you can also get in our documentation at the link at the bottom of this page. Second, you'll want to get the Windows 10 IoT Enterprise for Arm64 OS. And there's two flavors of this, remember. One is the general availability channel, and you can get that from a distributor, or the LTSC, where, as of today, it's still in a preview, and you would get that from the Partner Center. We have a portal in there called Microsoft Collaborate. Then you want to take this OS and you want to marry it with the BSP. So to do that, download the i.MX 8M BSP and user guide from NXP's website. There's a link to it right there. And then with that BSP, there will be a user guide to install how to install the BSP in Windows 10 IoT Enterprise on a device. And so that should get you started to building a Windows IoT Enterprise on the NXP platform. Now I want to show you a demo of the GPU running a very graphics-intensive workload on the i.MX 8M EVK. All right, so what I have here is Windows 10 IoT Enterprise running on an i.MX 8M Quad EVK from NXP. So it's running the Windows 10 IoT Enterprise LTSC bits. If you look at the window on the bottom right, shows the Windows version. You can see in the first line, Microsoft Windows version 21H2, OS build 19044.1288. And then the paragraph after that showing that it's Windows 10 IoT Enterprise LTSC. And then below that, you can see that this is obviously a preview version because it says activate Windows, go to settings to activate Windows, and then behind that, you can catch the glimpse of the test build watermark on the shell. So what I'm going to show you in this demo is really how the graphics, how the GPU driver really changes the game here. On the left, I am showing the task manager, and in the CPU window right above the graph, you can see that it's running the i.MX 8MQ, detecting the i.MX 8MQ. It's running it's got 4 cores, 4 logical processors, and it's been running for 4 days already, continuously without any issues. So kind of this is Windows IoT Enterprise. More stable than your average Windows device. Ha ha ha. Next, I'm going to go click into the GPU, and we're going to take a look at what's here. So, first off, Windows does detect we have an i.MX GPU device. It loads the driver, and because of that, you get this section in the task manager. And it's running the DirectX 11 version. It's running the DirectX version 11. And so what we're going to do first is we're going to show a benchmarking app that we call Dolphin. And we're going to run 2 versions of that. The first version of that, we're going to run it without using the GPU. So we're going to run it using Warp, Windows Advanced Rasterization Platform. And that means it's going to render on the CPU. And so we'll take a look at what the performance of that looks like, and what that does to the CPU utilization and the GPU utilization. And we'll compare that afterwards to what kind of performance you can get on the GPU. So just starting it up now. Let me close this window or minimize it. Okay. So now if you look at the top of this frame, it shows you the frames per second and the frame time, right? What this app is doing right now is it's drawing a dolphin with some fancy lighting, swimming around in the ocean, and it uses the DirectX 11 API, the same ones that run a lot of modern games like Halo and things like that, to draw all of this. And we're getting around 35, 37 frames per second. Now, if you go over to the task manager, you can see what happens when you're not running on the GPU. The CPU is pegged almost to 100%. We're using Windows Advanced Rasterization Platform to draw this whole scene exclusively on the CPU. And that consumes a lot of CPU compute time and cycles. So what that means is if you're running an app side by side with graphics that you're showing, that app's business logic, it could be getting sensor data or something, or sending data off to a gateway, is going to be it's going to be competing with the graphics that you're showing. It's going to competing with for CPU cycles with the graphics that you're showing, and that's not what we want. You can see that the GPU, by the way, the GPU is being utilized right now, and that's because we are running Windows, and the desktop Windows manager that's drawing these windows, for example, updating the FPS in real time at the top, updating the task manager, uses the GPU for acceleration, and so it's not the GPU is not completely at 0% utilization here, but that's because it's drawing the desktop shell as opposed to the actual graphics, and it's not actually being used to draw the graphics in the app. So let's see what happens if we launch the version of this app that uses the GPU. So you can see, the launcher, it said, found matching device, i.MX GPU. And if we put this in the foreground, if you look at the top of this window again, you can see that the frames per second, the FPS, is dramatically higher than it was previously. We're reaching 145, 149 frames per second, and it's pretty consistently above 140 frames per second. So that's a huge improvement in graphics capabilities. That's like a 4x improvement. But not only that, if we look over at the task manager, the CPU utilization has also dramatically dropped. So before, whereas you were using around 90% CPU utilization, that has come down all the way to 18%. And the GPU, on the other hand, is being fully utilized. It's around 90, 95%. And so that just shows kind of how utilizing the GPU hardware on the i.MX 8 platform, you just free up so much compute for your app's core business logic. And it's really powerful. It's something that we did not have for the i.MX 6 and i.MX 7. And with Windows's rich graphics capabilities, this is the same Windows that pretty much all big game video games run today. That powering the Windows IoT platform you can do a lot with it. I hope you enjoyed that demo showing the Windows graphics driver running on the i.MX 8 EVK. And I hope you enjoyed the session about the Windows IoT team's plans for NXP and really Arm64 silicon. Now, what we're doing on NXP is just one piece of a lot of different projects that our team is doing. And so I'd encourage you to go watch these other amazing sessions from other PMs and developers on our team. There's going to be there's a session on the Windows IoT Roadmap, Windows IoT Security, a feature called Dual Operator, which is very cool for Windows IoT that lets you use two screens on a single device. Project Haven, which looks into some of the cloud technologies that we're offering on Windows IoT, and the Edge Device Image Builder, which simplifies the workflow of building an image on Windows IoT. So go check out these sessions, and thank you again.